Thank you. Good morning. This is the last conference for me on a long Asia trip. I was in Singapore and Tokyo before this. So I'm kind of glad to be heading home tomorrow. But one more conference and lots of faces. Always nice to see. My presentation is online. You can follow along at this URL here. I'm on Twitter at Rasmus. So I started this a long time ago. About 22 years ago, actually, I started playing around with the web. Before that, I had been using or playing with IRC and other internet-based technologies before there was a web. But for the past 20 years or so, it's been all PHP. On June 8, 1995, I posted this message to a Usenet newsgroup. Looking around, some of you are probably too young to even know what Usenet is. But back before Reddit and Stack Overflow and things like that, we discussed things on Usenet, on newsgroups. So this is like Reddit, but for old people like me. And this was my announcement for PHP about 20 years ago. And it's almost like a time capsule of what the web was like in 1995. I didn't present PHP as a scripting language because nobody would expect a scripting language to be involved with the web. The web was a static thing, like a newspaper. You would go to a website every day and see what was new, just like you buy a paper. And like once you have the paper, it doesn't change. And back then, the web didn't really change. It was like a newspaper. But there was a lot of people trying to figure out who is reading this newspaper, who's reading my website. So a lot of this talked about logging and putting a database behind it and being able to do an intelligent thing about your web logs and things like that. Only down at the bottom here was there a hint at PHP as we know it today, where I talked about easily being able to create forms and then the ability to use that form information on subsequent pages. So that's the whole dynamic part of PHP. So that was kind of the public picture that I was showing to end users. Now for developers, my grand plan, which turned out to be a complete failure, was to create a C API for the web. So to me, you need a strictly typed, compiled language like C or C++ to build real software. You could script up things in Perl and write small utilities, command line tools like that, but to write anything real, I felt that you needed a strictly typed compiled language. And my idea was for people to write their applications in C, but I gave them the API and the framework to make it super easy. So they didn't have to understand the web very much. They didn't have to understand HTTP or the web server or any of those complicated things. All they needed to do was write the core of their application. So PHP was kind of two parts. It was the API and it was the templating system. And the templating system allowed you to make custom tags that you could then put in your HTML files. So in this case, I'm adding a cosine tag. So here, it echoes the cosine of some user input. And the way you would implement that using my API, which was stack-based, was you would pop the argument off the stack, check to make sure that it was valid, and then perform some operation, in this case doing the C-level cosine call, and then pop the answer or push the answer back onto the stack. And that's all you needed to do. You just had to write a function like that, throw it in the library, link it in, and now you would have this new cosine function or this new tag available to add to your website. I thought this was very slick and nice, but nobody cared. Nobody used it. I distributed PHP with a ton of examples showing how to use my API to add tags. But people ended up just using those example tags and then complaining and saying, we need more. We need, I mean, you have a cosine tag, or you don't have a tangent tag. It's like, well, it's so easy to add. Like, no, well, we don't know C. We don't care about C. We just want these tags. And it ended up to the point where I kept writing new tags, trying to explain to people how simple it was, and they were tricking me. It's like little kids almost. I bet you can't write a tag that does this. And I would say, look how easy it is. Here you go. I was like, thank you. Now I bet you can't write a tag that does this. And it was getting silly. But I did realize that the web was moving way too fast. And we needed way too many developers. And the developers that were being tasked with creating the web were not heavy-duty programmers. The really experienced professional programmers in 1995 did not care about the web. They thought it was silly, it was a toy, this whole HTML thing, it's a fad, it'll go away. This was not serious programming. But it didn't go away, and it grew really fast. And it grew in an interesting way. At many companies, when they first looked at the web, say, hey, we need to do something here. What can we do? Well, the easy thing is, let's put our product documentation online. So you go to your technical writing group and say, hey, you need to publish this online. And the technical writers look around and say, oh, okay. Word, save as, HTML, FTP, done. Perfect. What happened, though, was they now became the web team. So they were the technical writers, and they provided content both for the documentation and for the website. So they were now the web team. So when their boss next says, hey, okay, we have our documentation online, but people are asking, can they check inventory? Can they check if things are in stock? So web team, please connect to our Oracle database and provide a stock inventory management system. And this poor web team, full of technical writers, writing in Microsoft Word, they're clicking, saying, save as dynamic database website. That option doesn't exist in Microsoft Word. How do we do this? And that's where PHP began, and that's where it ramped up like crazy, because you had non-technical folks who were really just looking for a way to copy and paste and have stuff work right away. And nothing else was out there. There were some people doing things in Java, but you ask a non-technical person to solve the web problem with Java, just getting Java to spit out like hello world takes this much code, right? In PHP, hello world, you type hello world in a text file and you save it. That's it. It's the shortest hello world of any programming language anywhere, because by default, it outputs, right? So you don't even have to do bracket, question mark, PHP, echo, hello world. You just type hello world, and it spits that out. You cannot make a shorter hello world program in any language. And people loved the fact that it just worked. And the ramp up, the amount of learning they needed to do to get something working was tiny. Of course, it resulted in a lot of bad code. But it also resulted in a lot of problems being solved very, very quickly, which was needed because of the growth of the web. So, after years and years of growth and trying to catch up to all the requirements that you need when you're writing a complex application in a language, because as I said, PHP didn't start out with the intention of having people write the types of applications that you and the rest of the PHP world have been writing over the years. That wasn't the target. But we have been catching up, and we've been adding all the features, and we've been adding all kinds of things so that it's now very possible to do. And obviously it's possible because people have done it. But now with PHP 7, we've focused a lot on performance and also filling in a bunch of holes and inconsistencies in the language to get it to the point where now it is a very fast, very robust, mature language for writing complicated applications in. And the big thing about PHP 7 is the performance gain. We've had 3 guys mostly working very, very hard on performance over the years, over the last 2 years, I guess. So we now have over 100% performance gain on real-world applications, not on synthetic benchmarks, but on actual real-world applications. So you can expect, when you upgrade to PHP 7, whatever you're running will likely go about twice as fast as it did before, which means you could turn off half your servers, half your EC2 instances, if you will. Oops. There's some new features. One of them that also helps a little bit on performance is a persistent file-based cache for the opcode cache. And the opcode cache is that thing that sits and saves the opcodes in shared memory after they're compiled from disk and speeds up things a lot. So if you say that index.php takes 1x time to compile and execute, when it gets stored and when it gets compiled and then cached in shared memory, it's about 10 times faster. Now the new feature is that we can also cache it on disk, and loading the cached compiled opcodes from disk and executing them is about 4 times faster than doing it plain. So most of the time your website will be operating out of a shared memory, but there are times when you need to, maybe for log rotation, you restart your web server, which trashes the shared memory, which means it has to recompile everything and repopulate shared memory, which means your site is going to be slow for a minute or 2 after the log rotate, which for most people isn't a big deal. But for really large sites, really busy sites, being slow for a minute is really bad. So the fact that you can have a backup cache that you can repopulate from the file-based cache means that that hit of a restart is a lot less painful because you have the already compiled opcodes that you can bring in. Sort of a secondary benefit of this file-based cache is that for CLI scripts and cron jobs, things like that, they typically cannot use the shared memory cache because it's only for the life of the process. And as soon as the CLI script finishes, it kills the shared memory segment. So there's really no point of using the opcode cache for CLI. But with a file-based cache, that can now persist. So for example, if you enable it, which you do like this by setting a directory, and then telling you want the opcode cache enabled for CLI and turn on the opcode or the file cache, something like Composer, which is a large command line PHP script, the first time you run it with the file-based cached on, it took about 0.04 seconds. Then every subsequent execution took 0.019. Without the file-based cache turned on, it takes 0.033. So not quite twice as fast with the file-based cache, but still a good 35–40% improvement, right? Cron jobs, things like that, will run much faster with this. Plus the extra speed of PHP 7 on top of that, of course. This is what actually gets stored in the file-based cache. So Composer is a FAR archive, PHAR, which is like a PHP tar file. And inside that FAR archive are a lot of files. You probably didn't know that. Many of you probably use Composer already and think of it just as a sort of a standalone PHP script. But inside that Composer file, there's a lot of files. And they all get cached individually like this. So each of these files is an op array, we call it, which is an array of opcodes. Another new feature is the abstract syntax tree, or AST. What this does is it's a representation of the syntax that you can then do very interesting things with. For example, I wrote a little experimental static analyzer for it. So if you had a line of code like this, so echo substring, ABC, and then array 1, 2, which is obviously wrong. Substring does not take an array here. But this breaks out into this AST, where we have an echo, and we have a function call. The name of the function call is substring. This name not FQ means not fully qualified because I didn't put a backslash in front of it. And then the arguments, ABC, and an array. So static analysis becomes a tree traversal problem at this point. So I wrote this little analyzer that would walk this tree and find problems. So it looks for AST call opcodes, and it looks at the function, it's a substring call, and it has a database or an array of arguments that substring takes, and I just compare it, saying, okay, it takes a string and an int. Oops, well, we have an array here, and I can throw an error. I can say, hey, argument 2, which is supposed to be the start index, which is supposed to be an integer, is actually an array of integers, but it's supposed to take an int. So that's one of the things an AST can do, and I expect IDEs and all kinds of tools to start popping up over the next year or two that make use of this AST. Another new feature, return types. Pretty simple. You specify it like this, colon, and then the type, and that specifies that this function has to return an array. In case you don't return an array, in this case I'm returning an integer, you get a catchable fatal error. And it means that this can also be an exception, and you can catch that and do something interesting with it. But the point is that you can set return types. We also have scalar typing now. 2 modes to it. We have the traditional coercive scalar rules that PHP has used for a long time. So in this case, if I have a function, it takes a string, an int, and a float. If I pass in things that are not a string, an int, and a float, it will get coerced. So inside the function, you will get a string, an int, and a float, unless the coercion can't work. If there's no way of changing an argument into a string, like say if you passed an object without a toString method or anything like that, or a resource, like a MySQL connection resource or something, then you'll get an error, of course. Otherwise, it will coerce the arguments, and you will get those types inside. You can also turn on strict types mode, and that says, I really, really want the user to pass in these types. Anything else, even if they're close, no good. Then it's a fatal error. So if you turn on strict types and you don't pass in the exact types, you're going to get an error. Anonymous classes, pretty much exactly what it sounds like. Just like anonymous functions, you can create a one-time throwaway anonymous class and use it all in one go, like return new class like this, instead of having to define it. We've added a null coalesce operator. This question mark, it does not throw a warning on unset variables, which is the big thing people have been looking for, so that you can get away from this boilerplate is set empty checks that you always have to do to avoid those notices. And what it does is it returns the first non-empty in the PHP empty sense, the first non-empty argument. So in this case, A is null, B is 1, C is 2. A or B? Well, A is null, B is 1, so it's going to return 1. C or B? C is 2, B is 1, so it's going to return 2, because C is the first non-empty. A, B, or C? Obviously, again, B is the first non-empty. A, X, or C? Here, X is not even defined, but it doesn't care. It's not going to throw an error on this. A is null, X is undefined, C is the first non-empty, so you get 2, right? Very simple operator, but it can come in really handy and get rid of a lot of is-set checks. So you could always check, is this input provided or is this variable set? Otherwise, this is the default that we want here. We've added a spaceship operator. I talked to my son about the nature of the spaceship itself, and this is what he came up with, that if it was a TIE fighter, a Star Wars TIE fighter, it would look like that. TIE interceptor would look like that. So he says it's a TIE Advanced X1. is the actual name of the spaceship this comes from. And he's 13 years old, so he must be right. You use it to get rid of boilerplate type code like this. We had quite a few instances where people got their comparison functions wrong for user-defined sorts. So in a use sort, you have to provide a comparison function, and that comparison function should be stable. So if element A is less than B, it should return -1. And if A is less than B, then B should be greater than A, by just pure logic, right? But we had some comparison functions that would say that A is less than B and B is less than A. And both conditions cannot be true, but you can write a comparison function that gets this wrong, and then the sort gets all confused. Because how does it sort in a stable manner if the comparison function is unstable? So in order to fix that and to not have people think so much, you can just throw in the spaceship operator here, and it will do the right logic for you. Most fatal errors now have been turned into exceptions, which shouldn't cause any backward compatibility issues because an uncaught exception is fatal. So, and we also we have a different exception class for it. So even if you do sort of a catch-all exceptions in your current code, it still won't change its behavior. It just means that you have a bit more flexibility, and it'll be easier to catch fatals now in PHP 7. We've also added zero-cost assertions. We've had assert for a long time, but there was always a cost associated with them because the opcodes become compiled and the opcodes had to be executed. The real idea with assert in a compiled language is that in debug mode or development mode, they're there, but in production mode, they go away entirely because the compiler compiles them out. This is now what we do in PHP. You can tell PHP to not even compile in the assert opcode so that it has no effect, has zero performance effect, even if you have tons of asserts everywhere in your code. So it works like this. In this case, I have an assert with a condition and a message. So if I'm passing in something that is not greater than 20 and less than 110, it's going to say the arg is invalid. So here I'm passing in 16, 17, 18. All of them are invalid according to this. But we have a few settings, and you can turn assertions on or off. And at compile time, the only way to turn something off and have it not compiled is in your PHP INI. So if you set it to -1 in your INI, they won't even get compiled in. So they'll be completely skipped, and this assert line goes away entirely. If you set it to 0, it'll get compiled in, but it won't do anything. And then if you set it to 1, it will get compiled in and it'll be there. Setting it to 0 means that you can toggle it on and off in your code itself. So here I can turn it on, and here I've turned it off, right? So there's 3 settings to it, which is a little bit confusing. -1 means delete them entirely from the opcode cache. 0 means leave them in, but don't execute them. And 1 means execute them. That's why it's just not a Boolean. It's not just on or off. It has 3 states. We've added a closure call method, which means that you can basically call a closure and provide a class that closure should be bound to. There are some current issues around that right now we're working out, but that's the idea behind it. And we've removed a whole bunch of PHP 4 features. Most of them you shouldn't care about, like set magic quotes runtime, a bunch of weird stuff that you haven't used it in 10 years at least, and it's not going to affect you. Things that might affect you though is we've finally removed the old style regular expression, the ereg functions. If you're still using ereg, including the split function, you need to upgrade it. You need to change them all to preg calls or explode instead of split. We've also removed the eval modifier on preg. it was quite dangerous because eval basically evals some PHP code on user input, and there were so many security issues and applications out there. You could easily use it correctly, but we saw it used incorrectly too many times, and there are better ways of doing the same thing using a preg replace callback call. So use that instead, please. And a few other ones, old PHP 4 features like a new by referent assignment, other things like that. There are some new reserved words. So if you have a class named true, it's going to break. Hopefully you don't have a class named true or a class named null. Wouldn't make much sense. Drupal 8 had a class named string, which makes some sense to have that, but they have fixed it now. A few other things we've cleaned up, a lot to do with edge cases and numeric handling, also 64-bit support on Windows. Previously, even if you're on 64-bit Windows, you're still only getting 32-bit integers because of Microsoft compiler things. And this one is interesting. This actually caught a bunch of bugs in Etsy's, where I work, in Etsy's code base. If you provide an invalid octal, so any integer that starts with a 0 is an octal, and an octal only 0 through 7 are valid values, right? So if you have octal 0855, previously this would just set it to 0. There'd be no notice, no warning, anything. It would just set mask equals 0 and move on, which made it hard to find the bug. Now you actually get a parse error right away. So it'll be easy to track down these invalid octals. And this change is probably the one that's going to affect most of you, or it's the most likely one to affect you. In reality, it's probably not going to affect very many people, but if something does break your code, moving from PHP 5 to PHP 7, this is probably the one thing that will break it. And what we've done is, in order to have the AST be clean and consistent, we have changed everything to be left to right parsing when you have a bunch of things strung together. So in this case, we have this, then we have a property, then we have dereferencing. So that property is obviously an array, and we're dereferencing things in left to right order. In PHP 5, it actually looked in this belongs to property, which is an array, dereferenced and looked at what was in column. So if belongs to column was foo, it would then look up this foo, and that's what would get returned, the foo property at that point. In PHP 7, it goes completely left to right. So it first looks at this belongs to as a property on that, as opposed to just being array name belongs to with an index. It looks at the property belongs to, and then adds. It's a subtle difference between the two, but hopefully you see the difference between parsing this part first and parsing this part first. Everything is now left to right, which also means a whole bunch of things that never worked before now work. For example, calling a dynamically named function that returns a closure, which returns an array of closures, basically. So stringing a whole bunch of things together like that. It's a really bad idea to write cryptic code like this. Please don't write stuff that looks like this, like here, right? Returning a closure, calling the closure, all strung together. At least sort of split them on multiple lines and add some comments so people can read what the heck you meant. But the point is, this does work now. So you can do really ugly things like this or ugly things like this as well, right? And it will just work. I actually got bitten by one of these changes, and my presentation system is written in PHP. And I have this feature where I pick out a delimiter, which is just weird, random colon dash colon, followed by some string, colon dash colon, and I replace that. So for example, I can put the city where I'm giving a talk, I can put that in a slide, and wherever I'm giving the talk, the city's name will show up without me having to change the slide, because I have every presentation has some properties in this press object. So this was a very easy way of just using an eval and putting this object or this property named city in this string, in the text string here. This doesn't work anymore in PHP 7. So this is what I had to do to fix it. I had to use preg replace callback, look for the same pattern, so the things inside my delimiter, and then write a little closure, little anonymous function that says take the matches and then return this pret matches 1. But oops, left to right. In PHP 5, this worked because it took the matches array, which came in as an argument, and figured out what was the match, and then it would use that as the lookup, right? But in PHP 7, it does this first, which isn't right. This doesn't work at all because this is an array, and there's no array named matches like that or anything like that. So I had to put curly braces around it to force PHP 7 to do that part first. The nice thing about the AST, which caused this problem in the first place, is that you can use the AST to find the problem. So my static analyzer finds this stuff. It says there's a possible compatibility error on line 416. So when I ran my analyzer against my presentation code, it told me, hey, this isn't going to work on the PHP 7. It's fine in PHP 5, but in PHP 7, it's probably not going to work. So it might not be a bad idea to run my static analyzer or one of the other ones out there on your code when you're looking at migrating to PHP 7. Another new feature, there's a new syntax for adding Unicode code points into strings. So \u and curly braces around the code point that you want to add. So 22E is the right to left code point that switches from left to right, right to left. So anything you write after that is going to be right to left. And then, oh, it didn't work on this laptop. Interesting. This was supposed to be a weird smiley face, but obviously the font that this laptop is using is not showing it. My laptop does. There's a new ICU Intel char class. It's been added to the Intel extension. And we're hoping to, by the end of this month, or probably to be more realistic, the beginning of November. At this point, I should change my slide to early November. We're hoping for the final release of PHP 7. We're well into the release cycle, and I'll talk a little bit more about how you can help us with that in a bit. But a bit more on the performance boost that we've seen. Spearheaded by 3 folks, Dimitri, Chen, and Nikita, and one of them is in the audience. You'll hear lots from him later on. But they worked very, very hard, starting in January 2014, using WordPress. So 100 requests against the WordPress 3.6 front page took 26 seconds in January of last year. And it took 9.4 billion instructions to serve up. So these are low-level, machine-level instructions to serve up 100 front pages of WordPress. Now, slowly but surely, over the course of the year, so March, May, June, July, September, October, November, December, it shrank from 26 seconds down to 12 seconds, and from 9 billion instructions down to 2.9 billion instructions. And if you think about that a little bit, this is a pretty mature language. It's been around for 20 years. And you take something like WordPress and you say, look, we're going to show WordPress, or we're going to run WordPress, but you only get 1/3 of the instructions to do it. And don't break anything. It's like taking your complex code that's been around a long time and deleting 2 out of 3 lines. Like you only get to keep 1 out of 3 lines in your code. Keep 1, delete 2. Keep 1, delete 2. And don't break your code at all. That is not an easy task. It is really not an easy task. And it took a lot of effort. So some of the things that were done to achieve this, the zval, which is an internal unit or structure that we use to pass almost everything around inside PHP, shrank by 8 bytes from 24 down to 16. And since it's used everywhere, those 8 bytes add up very, very quickly. Hash tables are also used for just about everything in PHP. A little higher level than this eval, but still tons of them everywhere. Every array, everything you do, basically, the simple table, function, name of functions, classes, everything is in a hash table. They shrank from 72 to 56, and each bucket shrank a lot, from 72 down to 32. And you can see that combined with this optimization for immutable arrays and the hash bucket size decrease, code like this. So this keeps adding an array to an array. So you have an array of arrays with static strings in them. In PHP 5, this code took 43 megs. In PHP 7, you can run it in 6 megs. Now, obviously, this is a kind of contrived example that targets the exact optimization we did there. But still, in real-world code, you will see probably at least a 25% reduction in memory, maybe more, depending on the type of code that you have. Other things that were done, a lot of thought went into making sure CPU caches were respected. There's a new memory allocator, which looks a bit like jemalloc, if you're familiar with that from the C world. Iterate faster over hash tables now. Copying an array is faster. The JIT for PCRE, PCRE is the regular expression engine, has been enabled by default. And a bunch of other things. And a few of them only come out to play if you're using a modern version of GCC. So you might, if you're compiling your own PHP, or if you're getting it from a distro, you might want to check that they used at least GCC 4.8. If they didn't, you don't get all the performance boosts that you might otherwise have gotten. There's no JIT in PHP 7 yet. There might be one coming, we'll see. It's really hard to write even a bad JIT. Writing a good JIT is almost impossible. So, but we'll see. This part is exciting to me though, because we managed to get this performance increase without using the JIT. Adding a JIT that mainly addresses hotspots in code, meaning pieces of your application that gets executed a lot, the JIT directly addresses things like that. So what we've done so far, we've speeded up the base PHP. All of PHP is now a lot faster, but we haven't yet played the JIT card. Once we get a good JIT inserted in there, we could expect another significant boost in performance. So we have this ability still to get more performance out of this code. So I like that. I like that there's even more performance out there to be had. Because the effort up to now of making base PHP faster, I'm not sure how much further that can go. There's a few more things that can be done there, but you're not going to get a 2x boost anymore. It's going to be incrementals. The JIT, you could potentially get another 2x boost. So some numbers showing exactly what all these changes mean to real-world applications that you might be using yourselves. And please don't trust my benchmarks. I'm not trying to lie to you. It's not my intention. I don't have any motivation to lie to anybody about it. Nobody pays me for PHP. It's something I do, but I need PHP myself. But it's not a product that I'm trying to sell you. I don't really care if you use PHP or not. This is just what I saw. And I have all my information of what I use, the hardware, the software, all the configuration settings. You can go through my presentation and you can recreate my benchmarks from this. And there was actually a German IT magazine that did this. They had one of their staff go through and they built a box that was almost exactly like what I specified here. And they configured everything the same. And he sent me an email at one point saying, I'm not getting your numbers. Uh-oh, here we go. So I went through everything he had done. And it turns out he had forgotten to turn on OPCache. So I was like, okay, turn on OPCache. Like, oh, there you go. I see your numbers are within like 2%. My numbers are within 2% of your numbers. Like, perfect, great. So there has been at least one independent verification of all these numbers that I'm going to show you now. So first, Drupal 8. So this is PHP 5.4. We're getting about 1354 requests per second. And this is for 20 concurrent requests hitting it. PHP 5.5, a little faster, 1384. PHP 5.6 at 1428. PHP 7, 2555 requests per second at 20 requests concurrency. The numbers don't change that much when we increase the concurrency. This is at 40. If we go down to 10, not getting quite the same throughput. So the pattern is pretty much the same across concurrency. And here you can see HHVM for Drupal 8 is actually a bit slower. HHVM has not been optimized for Drupal. If we look at latency, let me turn off some of these. So latency at 20 requests, or 20 concurrent requests, PHP 5.4 was 15 milliseconds, 14, 8. So almost half, which means, and latency is the time between the request hits the web server and the first byte comes back. And latency, better latency means that the site feels faster. It feels crisp. It feels like you click and poof, immediately you have a page. It feels professional and it just feels more responsive. And cutting latency in half. So even if you're not a huge site, you're not Facebook, you're not Etsy, you're not Yahoo, even if you just have like a single server, moving to PHP 7, your pages will just feel better. They'll feel faster and more responsive. So even for small sites, there should be a lot of motivation to get onto PHP 7. WordPress. Now WordPress is interesting because you can see it's almost 3 times performance. One of the big reasons for that, and same with HHVM, both the PHP team and the HHVM team have been using WordPress as the guinea pig, as the test subject, right? So we've been optimizing code with WordPress in mind. So yes, both of them run WordPress really, really fast. With PHP 7, not quite as fast as HHVM, which bugged me a little bit. It's like, what the heck? And it's almost there, but not quite. So I used a trick. Now, the latest GCC has something called FDO, Feedback Directed Optimization. It's kind of like a simple JIT, if you will. What you do is you build a version of PHP using make profgen that generates a binary that's going to collect profiling information. Then I run it 1,000 times against the WordPress front page. And the front page pulls in most of WordPress because of the way WordPress is written. So most of the WordPress ends up being profiled in this case. So I run it 1,000 times against the WordPress front page. Then make prof clean, make prof use. This rebuilds the binary and it gives GCC, the compiler, the profiling information for WordPress specifically, and it's going to give you an optimized binary that is optimized to run WordPress. Now, if I took this and turned around and ran Drupal instead, it would probably be slower than my earlier Drupal numbers. But for WordPress, this binary is now geared directly at WordPress, and this is what we got. We were at 627 before, now it's 664, and this is within margin of error. 664, 666, it's the same. And we're there. And now, yes, it's a little bit of a hack or a trick, I suppose, but if you think about it, if you're a WordPress shop, all you do is WordPress, why not build a version of PHP that runs WordPress better, right? It doesn't take long. You just recompile and off you go. You should be building your own PHP anyway. I wouldn't trust some distro to build my PHP. I wouldn't expect you to. You should build your PHP targeted at the code that you want to run. All right, a few other things. PHPBB. PHPBB is the bulletin board package that you see all over the web, forums, people using it. PHP 5.3. 5.4, you can see we had quite a boost from 5.3 to 5.4 as well, but nothing like 5.6 to 7. And again, a little bit faster, quite a bit faster actually than HHVM on PHPBB. MediaWiki, this is another one that HHVM has been heavily optimizing for because of their working with Wikipedia directly. So here HHVM is faster than PHP. I haven't tried FDO on this particular one. But if you're running MediaWiki, you're probably better off using HHVM. Although there are some cases where you might not want to still run HHVM for that. OpenCart. Here, we don't get our nice 2x performance boost. And the reason is that OpenCart spends pretty much all of its time in the database. It has, every time you hit the front page, it sends like 20 full table scan queries at the database, and MySQL is just sitting there grinding away. And we're sorry, but there's nothing we can do in PHP that'll make your database run faster. You'll have to clean up your queries, do some caching, whatever. But still, I was actually quite impressed that we got any boost out of it. We did get a little bit, because all other versions of PHP, it's been pretty hard going. Almost no boost from 5.4 to 5.6, but 7 got a bit out of it. Wardrobe, this was one I picked just because it was a Laravel app. So there's a Laravel with a bunch of Symfony components in there, and showing that PHP 7 will run Laravel apps really, really well. If we look at latency on this one, again, latency is cut in half, essentially. Not quite half, but close to half from PHP 5.6. Geeklog, some random blog application I pulled off of GitHub. Again, not quite twice as fast as PHP 5.6, but almost. Magento. This is Magento 1, not 2. Magento 2 in production mode, I'm told, is a lot faster. I still haven't tested it, but I will. But here, the numbers are pretty low, as you can see. This is spending a lot of time in the database as well. But still, it's a lot faster than PHP 5.6. Track is a bug ticket tracking system. Much quicker. And one of the patterns here, you sort of see the same performance pattern, but one of the other things that you should notice with all these is that I downloaded these apps and just ran them. I didn't have to change them, except for this track one. This was the one application that didn't work right out of the box. And it was back to that same left to right problem again. And this was actually where I pulled that example from. It had code like this. Some model finder thingy, whatever, that was passing in that belongs to, that needed curly braces added. So I added the curly brace here and here, and then the application started working. Cache is a status page application, so you can run it off of EC2 or something. So in case your main page is down, you can redirect people to show the status. A lot of startups are using this, actually. Runs a lot faster in PHP 7. Moodle, educational software, used a lot in United States and Europe. Maybe not so much in Asia. I'm not sure how good their Asian support is. A lot faster again. ZenCart, this is another shopping cart. For some reason, e-commerce applications tend to really eat the database. So again, pretty much no change from 5.3 to 5.6, and then a slight jump for PHP 7 because it's database heavy. I couldn't get this one working in HHVM, actually, so I don't have HHVM numbers. And finally, help us out, please. We're getting ready to release PHP 7 in another, hopefully less than a month, maybe about a month. And the one way to irritate and annoy us is to, the day after the final release, file a bunch of bugs about your applications breaking. Please file those bugs now, before the release, so we can fix them before the final release. We'll be a lot happier and friendlier towards you if you file a bug tomorrow versus filing a bug in a month. In a month, we might get a little grumpy and saying, hey, what the heck? You've had like 8 months to find and report this bug, but you do it right after release, the final release. So please do it soon. It's really, really easy. There's a whole bunch of ways to do it. Just grabbing the source code off of GitHub and compiling it, if you know your way around compilers, is one way of doing it. Another way is to grab my Vagrant box. So you need Virtualbox installed and Vagrant, of course. But if you have those two things installed, you can just do a git clone of this repository, cd into it, and type Vagrant up. It'll download the image, and you can now Vagrant SSH into it, and you'll have my development environment, essentially. So I essentially took what I use every day to develop PHP and created this Vagrant box that has the whole environment inside it. It's a Debian image with a whole bunch of stuff. Default IP is this. It'll probably pull a DHCP IP as well. Inside it, you can switch PHP versions really easily. Just type new PHP, and the version, so new PHP 5.6 will switch the whole environment to PHP 5.6. New PHP 7 debug will give you PHP 7 debug. And it's one way of testing your applications very quickly against different versions of PHP. So if something is broken in PHP 7, you can quickly switch back to PHP 5.6 and make sure that it's actually PHP 7 breaking it and not something in the environment. There are 20 pre-compiled versions from 5.3 up to 7, debug, non-debug, thread safe, non-thread safe, all the way through. You can rebuild PHP 7 just by type make PHP 7, and it'll pull the latest version and recompile it just to update your image. You can also do it manually if you wish. And here's the image again. This, grab it here, git clone this to get going with it. And I think I have maybe 4 minutes for questions, hopefully, maybe a little longer. This is always the most interesting part for me, is to hear what you guys have on your minds. So please don't be shy. We probably have some microphones as well around. No? Questions? Questions? Hands? Yes? I can repeat the question. So the question is, am I still doing anything at all? Obviously not as much as in the beginning. In the first couple of years, from like 94 till 97, 98, it was pretty much 100% me. And I would spend 16, 17, 18 hours a day doing nothing but this. I can't do that anymore. First of all, I'm just too old and lazy to do it. And I have a son, I have a family, and I think it's more efficient for me to do more of this, to travel around, to talk about the work that we do, to motivate younger developers who can spend 18 hours a day, who are smarter than I am. I mean, we have lots and lots of developers out there who are way smarter than I am and way better developers. My goal is to get to the point where there is 0 lines of my code left in PHP. And I think that should be the goal of pretty much every developer, actually, that any project that is progressing and moving, hopefully it's not limited by one main developer. If it is, the project is dead and has been dead for a long time. The project needs to evolve and move on, and old code needs to go away. And so my goal is to have 0 lines of code left that are mine. I do occasionally. I haven't built any major features in PHP for a long, long time. I do fix the occasional bug. I go through the bug database, fix stuff, or I sort of behind the scenes talk to people about specific bugs and track them down and give them really good bug reports and help other developers track things down. And I kickstart a lot of other developers as well. I sit down with them and show them, especially at Etsy, I've been getting a few guys up to speed, showing them how to write an extension and how to debug PHP and what all the different internal things mean. So no, I don't do a lot of core development anymore. I do more things sort of just around the edges of core.
Hello, I'm Steve. I have a question about you fix the zero, the memory, with the starter of your memory.
Yeah, the zval memory?
Zval, yeah. But the PHP still have a bottleneck on the I/O speed. You don't.
I'm not sure we
touch
call it bottleneck. You're talking about async stuff? Is that what you're getting at?
Yeah, about a couple of things. If PHP loading a bigger file system, you try to loading on every page, they will be getting slow and slowly.
Loading what on every page?
Loading file system. If your project, the file is too big, a lot of huge.
But we don't, on most requests, we don't touch the disk at all. Everything comes out of shared memory.
Yeah, for specifically the couple of case of Zen framework, the file is too much, so it's speed very slowly.
No, even frameworks, everything gets cached in shared memory, unless you have your shared memory OPCache set to be too small. The entire framework should fit. So I'm not sure what you're talking about coming off the disk on every request. Nothing should be. At Etsy, for example, we have tons of code, and I have a 3 gig OPCache segment, and everything fits in shared memory twice. We never touch disk.
So we don't have a file system.
You shouldn't. If you have something that's always reading a file on the disk, then it's code that you have written, where you explicitly do fopen, fread, or something. And then you should fix your code and cache it somewhere in memory so you don't hit the disk. But yes, I agree. I/O is slow. There's nothing we can do to make that faster other than cache. And we do cache our stuff. We can't cache your application stuff because we don't know what you're doing.
Yes, we also know the require ones and require is different, right?
But they still come out of shared memory.
Yeah.
Both of them.
Thank you.
I have a question. Does PHP 7 still have the same variable type cast rule as old one? Like a string with 0 will be judged as 0, will be cast as 0 in like a list cast
I understand.
rule.
So no, the casting rules have not changed.
It's all the same.
It's all the same. Changing those casting rules would introduce a lot of backward compatibility issues. Yeah. Yes. There is a good argument to be made for some of them to change a bit, but we have not changed them.
Okay. Because PHP cast rule sometimes will confuse the developer because there is a very weird cast rule in here.
Right. But again, we have to balance that against breaking existing code, right? So it's tough. I mean, you could simply turn on strict everywhere you go, then that's not an issue anymore because there's no casting anymore. You have to pass the right arguments everywhere. So for new code, you could write code like that. I think that would be painful, but you could do it that way. But no, we haven't changed them for PC issues. We want to make sure that it's easy to get people on to PHP 7. We may revisit that. If we come up with a good way of doing it without breaking everything, we could revisit that. Thank you.
感谢 Rasmus 为我们带来最精彩的分享。